The main keywords we will be learning in this attenuation topic are attenuation, absorption, scattering losses and bending losses. These are the four main words we will be coming across during the complete unit process or during the complete topic of signal distortion. Okay, so what are the loss that can be incurred in a signal transmission, why it occurs, to what extent that loss is acceptable, why that loss occurs, and what is the difference between attenuation and distortion, you will be knowing in this particular lecture. First, coming to the attenuation part, attenuation is the measure of how much amount of decay in the signal strength or loss of light that is happening when that particular signal is transmitting through a length of the fiber L. So if you are transmitting a power P naught at the initial point, the same amount of power is not reaching to the end of the fiber P of L, that is the total length. Okay, so what is happening, why this difference is occurring? This is due to the attenuation of signal power. Okay, and this attenuation determines number of repeaters that are required in the communication system that is installed. Suppose if you want to install a communication system over a distance of 200 kilometers, and in the length of, for every 50 kilometers you are able to see an attenuation of 1 dB per kilometer, then for every 50 kilometers you need to have one repeater, so that the 1 dB loss what you are encountering for 50 kilometers each will get reduced, so that the information will be gained and it will not be lost. So this attenuation measurement will also be helpful how the signal strength can be retained, at what part we have to install our repeaters. And this attenuation can be of three types. One is absorption loss, second one is scattering loss, and the third one is bending losses. These are the three main causes of attenuation in any optical fiber. In this, first we will see how to calculate the attenuation for a length of fiber, and then we will go in detail of the three causes of the attenuation. Suppose here I am considering an optical fiber of length L. The initial power is P of 0, and for over a length of L the power is P of L, okay, at Z equal to L. Okay, so the output power P of L is given by P of 0 into e power of minus alpha P into L. This alpha P is your attenuation constant. Attenuation constant determines how much of amount of loss that encountered when this power P of 0 is transmitted through a length of L, and P of L power is received at the ending part. And when we convert this power expression into its logarithmic form, so that we can get the power in dBs, then alpha P, the attenuation constant alpha P, is equal to 1 by Z of ln of P of 0 by P of Z, and in dBs, that too in terms of log, we can write it as 10 by Z into log of P in by P out, we can say, or P of 0 by P of Z, or in terms of Z we can include L even. So this is the expression for attenuation constant. By using this formula we can determine how much amount of attenuation for over the length L can be determined, and where the repeaters can be placed. This graph shows what amount of attenuation is occurring at different windows of operation. As you know, optical wavelengths are mainly confined to three windows of operation. First window is around 850 nanometers, second window is around 1300 nanometers, and the last window, third window, is around 1450 to 1500 nanometers. Generally, optical wavelengths are in these three windows only. The signal distortion, here you can see the attenuation at the lower wavelengths is very less, whereas in the second wavelength, when the signal is operating at the second window, that is 1300 nanometers, the attenuation has increased drastically. At the higher wavelength, that is your third window, it has been reduced. So from this graph what we can observe is, if the light is operating at the second window wavelength, or if the the operating window is second window, then we can observe more attenuation than the first window and last window. Generally LED sources will be operating in the first windows, laser lights will be operating in the second and third windows. We can change our sources, their wavelength range, our light range also. In any range of, in any window we can operate. So basing on choosing this amount of attenuation in different windows, we can choose our wavelengths so that we will not have much amount of loss. So this is about the attenuation. Okay, in the next class we will discuss about the three causes of attenuation, that is absorption, scattering losses and bending losses. Firstly we will discuss about absorption. Thank you.